Hey, we have here an integral and I forgot to write it down. Hey, we have here an integral from MIT Integration Bee 2010 and I forgot to write it down. So let's do this. We have problem number 22. We're integrating from 0 to 1 x cubed ex squared dx. Okay, at first I thought it was looking a little like the Gaussian integral, but we don't have a minus sign there. We don't have the infinity in our bounds. So instead what I wanted to do is let's see if we can just simplify this x squared just with a u substitution and see if we can turn this into something we can deal with. So I'm going to say u equals x squared, and then we'll integrate and we'll say du equals 2x dx. I think before I do the substitution, I'm just going to rearrange this into this form to make it clear. So I'm going to write a 2x dx here, noticing that's du, and then in front I'm going to have 1/2 x squared, noticing half x squared times 2x is x cubed. Okay, now I'm going to make this substitution. So first we'll update our bounds. Plugging a 1 in to x squared is just 1, and plugging a 0 in to x squared is still 0. So our bounds don't change. That's very nice. I'm going to take this half out front, so let's just write the half here. X squared is going to be u. E to the x squared is just e to the u. And this part, again, is du. This is really not bad. This is a pretty good situation. For this, we'll do integration by parts. I'm going to do the DI method, tabular integration. So we'll integrate, and in a case like this, because the exponential is going to persist, but the polynomial, or just the u term here, we can differentiate that all the way down to 0. So I want to differentiate my u, and I want to integrate eu. So integrating this multiple times, integral of eu is just e to the u. Derivative of u is 1. Derivative of 1 is just 0. Now this last row would be an integral, but notice we have a 0 here, so that zeroes that out. So we don't have to worry about that. We can just go to our solution on the diagonals. So what I'm going to do here is I'm going to factor in, because we have e to the u in both terms, we'll factor in e to the u out front, and we're just left with these terms. So we're going to have u minus 1, and we're just evaluating this from 0 to 1. Now I can plug a 1 in here. We'll have a half e in front, but when we plug 1 in here, this is just going to be 0, 1 minus 1, 0. So the first part's going to be 0. Then plugging a 0 in, we're going to have our half. E to the 0 is 1. 0 minus 1 is minus 1. And so we're going to have a nice final solution. Just multiplying minus 1 times minus a half, we get 1 over 2. So that's it. Good quick problem. So thanks everyone for watching. Have a great day.